For the people who haven't seen it.
Everybody dies.
Except for the people who live. Alright, there may be a Star Wars question on the final. There was a question about the New York Yankees on my probability midterm.
You must review.
I gave a hint that it was about who won the World Series, and I gave a hint that the Red Sox won the World Series. So in terms of calculating probabilities. Alright, good. We're now up to full strength.
If there is a Star Wars question, can we be assured that it won't come from material that's too recent, as in from the newer trilogy?
There's a newer trilogy? It'll either come from 4, 5, or 6, or Star Wars canon literature.
Okay.
Star Wars canon literature. There's
Yes,
a bunch of books about Star Wars canon.
we'll talk about that later. So,
Who dies?
who remembers the function we were
Yeah,
looking
but
at last
Wikipedia
time?
has it all for you.
That's true.
Who has the function?
But Wikipedia
Who remembers the
reads
function?
1/2 minus the outside of x. For x is greater than.
Well, I mean, that's understood. I mean, that's, so f hat of 0 was 1/4, I believe. And f hat of 2n plus 1 was 1 over, was it pi squared? 2n plus 1 squared?
Yeah.
Okay. So what I want to do is I want to calculate the sum of 1 over n squared and the sum of 1 over n to the 4th. I apologize, last time I kept saying Plancherel. It's actually Parseval, not Plancherel, so apologies.
It's a tripology.
Plancherel is talking about the L2 norm of f is the same as the L2 norm of f hat. And of course what we have here is the sum of the squares of the Fourier coefficients. It's very similar. It's Plancherel type, but Parseval gets his name attached here. It's just one of the mathematicians whose names begins with a P.
So everything we did with Plancherel
Is technically possible, or generalized Plancherel. This is why in bridge, when I play bridge, I always use Jacobi and Stamen conventions, because this way I don't have to remember which convention is Jacobi, which convention is Stamen. So let's study the sum, n goes from minus infinity, well, we'll do m, goes from minus infinity to infinity, of f hat of m squared, and that's supposed to equal the integral from minus a half to a half of f of x squared dx. Well, if we look at the left-hand side, this is going to be 1/4 squared, which is 1/16, plus the sum. And now if I look at all the values of n, really I can just go and, n goes from minus infinity to infinity of f. So it's going to be 1 over pi to the 4th, 2n plus 1 squared. And now when I integrate, I have to integrate the function 1/2 minus x squared. When you do the integration, it's 1/12. So the integration of x minus 1/2, I'm sorry, 1/2 minus absolute value of x squared is not so bad. This is just twice the integral from 0 to 1/2 of 1/2 minus x squared dx. So you get 2/3 1/2 minus x cubed at 0 and 1/2. But with a minus sign, you flip the orders. And so you get 2/3 times 1/2 cubed, which is the 1/12. And if we look at what goes on over here, I have essentially the sum over the odds, but twice.
Is it 2n plus 1 to the 4th?
2n plus 1 to the 4th, thank you. This is probably a little bit hard to see backwards. So, does this look like I'm going to be able to get the sum of 1 over n squared from this? Alright, so we'll have to put that in our to-do list for later. But maybe we can at least get the sum of 1 over n to the 4th from this. If I take the 1/16 and subtract 1/12 minus 1/16, that I can do. And then what I really have over here is I have twice over pi to the 4th, the sum, m odd, 1 over m to the 4th. Okay? And so now what's 1/12 minus 1/16? I pull out a 4th and I get a 3rd minus a 4th. That's going to be 1/12. So I think it's going to be 1/48. Or is it 196? Is it a 48th? Yes, it's a 48th, good. And then when I divide by the 2, I'll get 1 over 96. Alright, so I have a formula for the sum over m odd. But I really want the sum over all m, not just m odd. So the question is, what can I do to get the sum over the remaining? So let's consider the sum over all m of 1 over m to the 4th. It's the sum over m even of 1 over m to the 4th plus the sum of m odd 1 over m to the 4th. I claim one of the two sums on the right is masquerading as a close cousin of the sum on the left. Which one of these is essentially the same as something on the left?
Evens?
The evens. What's the relationship between the evens and all? 1/16. I can write the sum over m even. This is just the sum over all m of 1 over 2m to the 4th. So 2 to the 4th is 16. I bring that over here. I have 1/16, the sum over all m. I have sum over all m. So I get 15/16, the sum over all m of 1 over m to the 4th is the sum over m odd of 1 over m to the 4th.